Hi, I'm Craig. Now I know I may look like I'm just some crazy guy spraying a rock with a garden hose, but I'm actually attempting to get rid of it by replicating a common geologic process. If I spray this rock long enough, it'll eventually erode away, kind of like how rivers can level entire mountains over time. The only problem? It can take thousands or millions of years. You know, there are a number of other geologic processes that can drastically change the landscape. Volcanoes exploding, glaciers, glaciering. And today, we're going to look at one process that's way more catastrophic, and it can only be described as earth-shaking. I'm just assuming they want this rock moved. This isn't even my house. We're here with a planetary geologist from Ohio University, Dr. Keith Milam. Keith, where are we today?
We're here in Adams County in southwestern Ohio.
Now, Keith, you told me that you were going to show us evidence of a big geological change that happened around here, but I don't see anything.
Well, Craig, we're actually standing in it.
I've been standing in it all week.
No, I mean we're standing at the center of the geologic change. We're at the center of the Serpent Mound impact crater.
Oh, what exactly is an impact crater?
Well, an impact crater results when you have a large object like an asteroid or a comet traveling through space. It enters our atmosphere and collides with the surface, smashing into it and excavating a large hole.
Yeah, okay. Sounds like someone here has been watching a little too much of the science fiction channel.
Well, it may sound like science fiction, but it's actually science fact. Space rocks large and small are hitting the Earth all the time. Sometimes the small ones will burn up in the atmosphere, and then sometimes the bigger, the faster ones can make it through, and when they do, a collision takes place and can excavate out an impact crater. Take a look at the landscape around us. You'll see that off in the distance, the elevation is much higher than where we're standing right now.
Yeah, it's almost like we're standing at the bottom of a gigantic, empty swimming pool.
Yeah, in a sense, except the impact event took place hundreds of millions of years ago, and since that time, a lot of erosion and weathering have really sculpted this landscape into what you see today.
Wow. With a crater like this, that space rock must have been packing some serious force.
Oh, absolutely. In fact, the amount of energy that was released during this impact event was enough to permanently damage the rocks around here. If you want to, I can take you down into a gully and show you some of the damage.
Let's go.
So Craig, the force of the explosion was strong enough that it really permanently damaged the rocks that are here at the center of the crater. In fact, when you look down at your feet, you can see evidence of this. Here's a rock that has been damaged by the force of the explosion. This rock has special fractures in it, cone-shaped fractures called shatter cones. We only get this during impact events. And for a point of comparison, I brought along another rock from outside the crater to kind of show you the difference.
Oh, wow. There's clearly a difference. Wait, so you're telling me that the force of the impact shattered this rock into pieces?
Oh, absolutely. So it kind of gives you an idea of the amount of energy that would have to be released to damage these things.
All right, Milam. So far, your story holds up. So Keith, take us through what happens in a cosmic collision.
Well, for such a collision to take place, you really need two things. First, a smaller object, a projectile, or an impactor, like an asteroid or a comet. The second thing you need is a larger object, like a planet or a moon.
You made these props yourself, didn't you, Keith?
When these two objects, they're orbiting the sun in their own somewhat circular paths. Those paths, when they eventually cross each other, collision will take place.
Well, how big of a collision are we talking about?
Well, that really depends upon the mass of the two objects and how fast they're moving.
Oh. Well, is the Earth the only planet that experiences these collisions?
No. In fact, almost every planet or moon in the solar system has impact craters on its surface. If you look up at our own moon, you'll see the entire surface pockmarked with evidence of these impact events, where space rocks are constantly colliding with the moon. So Craig, we can actually simulate what happens when a space rock hits the surface of the moon. Behind me we have a container full of colored chalk and flour, and that's going to represent the surface of the moon. For our projectile, we're going to use a paintball. So the paintball is going to essentially represent our asteroid or our comet that's going to be fired by the gun. So it's going to provide the force for the impact event itself. Would you like to do the honors?
Would I like to play with the paintball gun? Yes, please.
Here you go. Wait. Safety first. Don't forget the goggles.
Yeah.
Nice shot.
Not really. I was aiming for my director.
Well, anyway, would you like to see the crater you made?
Yeah.
Let's take a closer look. So when the projectile, in this case a paintball, struck the target, it exploded. It's this explosion that excavated the flour and the blue chalk and even pieces of the paintball itself out away from the crater, leaving behind a bowl-shaped depression we call a simple crater.
A simple crater? Are there more complicated craters?
Oh, sure. The larger ones, they can produce bigger bowls, if you will. Larger craters whose walls can collapse, and sometimes centers can rebound, forming a peak.
Kind of like the hill we were standing on at the impact crater site.
That's exactly right, just like the one at Serpent Mound.
Aside from making planets look like golf balls, what do these impacts do?
Well, the larger ones anyway have the ability to dramatically alter our own planet. It can really have an effect on our own atmosphere, our hydrosphere, our biosphere even. About 65 million years ago, there was a large impact in Mexico in the Yucatan Peninsula. It was so large that it may have led to the mass extinction of about 2/3 of all life on this planet.
Wow, that's a catastrophic collision. Sorry, they want me to work the title in somewhere. It's the business for you.
Yeah.
Now let's get out of here. So geologic processes can transfer a lot of energy. Huge impact events can blow large amounts of earth up into the air like crumpled pieces of paper. But even something as seemingly harmless as a river has the power to completely change a landscape over time, which is kind of cool. So if you need some natural landscaping done and you've got some time to kill, consider waiting around for a catastrophic geologic process. But if you can't do that, try making a catastrophe of your own. I don't see how this could possibly go wrong.